In this video, I'm going to explain what an element is, what a compound is, and what a mixture is, and how they are different from one another. Now you're going to see a complex formula here, but don't worry about it, that's not relevant to what I want to explain. Let's assume that we have some copper-2 nitrate crystals which are blue in color. Now, if we heat these hydrated crystals, we're going to be left with black copper-2 oxide, which is a black powder, and you can see that it becomes a much simpler substance compared to the copper-2 nitrate crystals. If we pass hydrogen over this copper-2 oxide, that hydrogen will remove the oxygen and it will leave us a very pinkish brown copper here. You can see here that copper is a much simpler substance than copper-2 oxide. Now, when we get copper, there is nothing that we can do chemically to turn this copper into anything simpler at all. That makes copper an element. Because why? An element is defined as a substance which cannot be split into anything simpler by chemical means. They all contain the same number of protons. If copper is an element, then we're only expected to see copper atoms here. This table is an arrangement of the chemical elements known to us, organized by the atomic number. So what is an atomic number then? If we take a look at this notation here, we see the chemical symbol O accompanied by the number 8. What does it mean? What it means is if we take a single atom of oxygen and zoom into it, we'll be able to see that there is a nucleus in the center and there is going to be electrons that are surrounding the nucleus. And if we count the number of protons, which is in the middle part of the atom, we'll be able to see that there are 8 protons inside it. And because this particle has 8 protons, this atom becomes an atom of oxygen element. In a way, we can also say that the proton number is what defines what an element or a substance is. Therefore, the definition goes like this. The number of protons in the nucleus of an atom is called a proton number or an atomic number. You can see potassium is 19, calcium is 20, scandium is 21, titanium is 22, vanadium is 23. So the table is arranged in the order of increasing number of protons and the atomic number. Coming back to this model here, the final substance that we have here, which is the pinkish brown copper here, is definitely an element because all the atoms that make up this copper pile here, every single individual atoms in this model will have the same number of protons, and that is what makes copper an element. Now, if we have an element, what it means is that all of the atoms in a model will have the same size, shape, color, and most importantly, the atomic number. Let's take a look at a model of helium gas here. We have atoms in this model, and all of the atoms in the model, they have the same size, they have the same shape, they have the same color. Therefore, this represents helium gas as an element. Let's take a look at the word molecule. A molecule is an electrically neutral particle which is made up of a fixed number of atoms which are chemically bonded together. In simpler words, if we take a look at the model here, is this an element or something else? This is still an element. Why? Because all of the atoms in this model here have the same size, same shape, same color, and same atomic number. However, this is an element made of molecules. Helium is an element made of atoms. That's the difference. If we take a look at a sample of copper, this will be a copper element because all of the atoms in the model, they have the same size, same shape, same color, and most importantly, same atomic number. Let's take a look at our last model here. The model consists of molecules. Each molecule is made out of one nitrogen atom and 3 hydrogen atoms. So this model is no longer an element because they don't have the same size, shape, or color anymore. We have more than one element here, which have different atomic numbers. So if the atoms in a molecule have different atomic number, then what we have here is a compound. One of the things that I want you to pay attention to about compounds is this. Compounds contain molecules which are made up of a fixed number of atoms chemically bonded together. I have a model of ammonia gas here. The formula of ammonia is NH3, where there is one nitrogen atom and 3 hydrogen atoms. Every single molecule that I will find in this model must have one nitrogen atom and 3 hydrogen atoms. There cannot be a molecule where there's only one nitrogen atom and 2 hydrogen atoms. It will not exist. Let's try to understand our terminologies better through these examples. The helium gas will be an element which is composed of helium atoms only. Hydrogen gas will be an element which is composed of hydrogen molecules because hydrogen exists as a diatomic molecule. Carbon dioxide is different from hydrogen because in a molecule of carbon dioxide, the sizes are different, the number of protons are different, the shapes and colors are different now. So carbon dioxide is no longer an element, but a compound which is composed of carbon dioxide molecules. If we have a piece of solid potassium, that solid potassium will be an element which is composed of potassium atoms. Another way to try to see this is by using the formulas as well. If we have only one symbol, such as carbon, copper, hydrogen, and nitrogen, only one symbol for the name, then that will be an element. If we have more than one symbol for our substance, such as carbon dioxide, there is C, there is O. For water, there is H, there is O. For NaCl, sodium chloride, there's Na, there's Cl. For ammonia, there's nitrogen and hydrogen. If there's more than one symbol, that substance would be a compound. Notice here that although we have H2 and N2, they are still one symbol only. That's why they will be elements. Now let's talk about one of the confusing topics. What is the difference between a compound and a mixture? A compound is defined as a substance which is made of two or more different elements chemically combined together. What does it mean? Now we have a cup of water here, which consists of water molecules, which are chemically combined like this. Water is a compound because the water molecules cannot be separated by physical means. If you heat up the water here, this will go from water liquid to steam gas. If we freeze this water, this will go from H2O liquid to H2O ice. But we will not be able to separate the individual atoms of hydrogen and oxygen from a molecule of water separately. The second statement says that the properties of a compound are different from the elements. What does it mean? Hydrogen as an individual element is very explosive. Oxygen as an individual element is also very explosive. But when they chemically join together to form a new molecule called H2O water here, they're no longer explosive. It becomes drinkable, which means that the properties of a compound become different from the elements that make the compound. A mixture is defined as a combination of two or more substances, which could be elements or compounds, that are not chemically combined. I'll explain this through an example. Now I have a pile of sand here and some iron filings here. If I mix two of them together, I'll get a mixture of sand and iron filings, but I did not get a new chemical compound of sand and iron. I just get a mixture of sand and iron here. And they are a mixture because they can be separated by physical means. If I were to run a magnet over this mixture, the iron filings will attract itself to the magnet. Which also supports our second statement where it says in a mixture, it will show the properties of all its constituent elements. We did not form a new chemical compound, so there is no new property. The iron filings are still retaining the original properties, and that is why it is able to attract itself to the magnet here. Elements and compounds are considered to be pure substances, and therefore, if it was an element or a compound, it will display exact and sharp melting points and boiling points. If it was a mixture, because of the presence of impurities, it's considered as impure substances, and just like in previous video, mixtures will always have a range of melting points and boiling points. A cup of clean distilled water is a compound made of H2O molecules, meaning that every part of this liquid here that you see are all H2O molecules. So therefore, it should display an exact melting point or boiling point. On the other hand, because we have impurities, dirt, and sand inside this cup of dirty water here, is impure and will show a range of melting points and boiling points. That's it for today's lesson. Leave a like if it was helpful to you. Share with your friends who are having difficulties on elements, compounds, and mixture. And I'll see you all in the next video. Bye-bye.